So let's so please make sure you create a new project for today. You can create CSE114 Spring 16 Week 06 and then Lab 1. Create one. I'll wait for you. And I just need one package for myself. Session 1. Okay, and then we need another one. You don't need to create the packages, it's only for me because I'm teaching 2 sessions. Okay, so now we need a class. Let's call that, I think, matrix operations. Okay, so now let's create a new class here, just call that matrix operations. Okay, with a main method there. As you can see on the second page, that's the list of tasks you are supposed to complete. So the first one, you should really prompt the user for the matrix number 1. So since we're going to, well, whenever you do any addition, subtraction, or multiplication, you need 2 matrices, M1 and M2. So we're going to ask what's the dimension size for matrix 1, and then initialize matrix 1 accordingly, and then what's the dimension size for matrix 2, and then initialize matrix 2 accordingly. So that's sort of the flow. So now we're going to need the scanner over here. So let's declare the scanner here. Scanner input new scanner system.in. Okay, so now we're going to first of all prompt the user for the number of rows of the first matrix and then the number of columns. So system.out.println. You can just assume the user is going to enter positive numbers for now. Okay, so we just avoid the error checking for this exercise here. Enter the number of rows of, I'll just say M1, matrix 1. Okay, and then we're gonna have input integer. I would say the number the number of rows of 1, matrix 1, okay, is equal to assigned to input dot next int. Okay, I think we might have to use the read line later. So just to be safe, you can say input dot next line over here, just in case. Okay, that's the number of rows. I'm gonna do the number of columns as well. System.out dot println and enter the number of columns of M1. Okay, you can put a column here. And input dot integer the number of NC1 input dot next int, and to be safe we can also say next input dot next line after that. Okay, so now we got the dimension size for the first matrix, so now we can initialize that matrix accordingly. So now this is how you declare the 2-dimensional array. You say integer, 1 pair of square brackets will be 1-dimensional. So now it's 2-dimensional, so there should be 2 pairs of square brackets. You can say M1 over here, and now it's equal to, and similar to how you initialize a 1-dimensional array. New keyword here, integer, like that. So now we can say the number of rows will be NR1, number of columns will be NC1. Okay. And now, task number 2. We are going to let the user to actually enter the cell one by one. For example, let's say if the user say the number of rows is 3. Let's say the number of rows is 3, and the number of columns is actually 4. So like a 3 by 4 matrix. So 3 by 4 matrix. So we got 1, 2, 3. In this case, we got 12 slots to fill in by the user. So the way you're going to ask the user to fill in would be start from 0, 0, and then 0, 1, 0, 2, 0, 3, and then the next one, 1, 0, 1, 1, etc. Okay? Apparently, to do this, we need our nested loop that we did in the class, right? That's something we're going to do. Okay, I will show you how you can do it. It shows quite nicely how you can actually initialize the two-dimensional array one by one. So let me show you. So now we're going to need our standard loop for two-dimensional array. Integer r equals 0 r less than m1 dot length and r plus plus. Okay, and the inner loop is going to go over column by column. Integer c equals 0, c less than m1 r dot length and c plus plus. So now for this particular m1rc, we're going to ask the user to enter a value. So over here, we're going to say the following: system.out.println. Enter a value for, so it's going to be m1. Okay, it's going to be the index for. Let me just separate into two print statements so that's easier for you to read. Enter a value for m1. System.out.println. Okay, we're going to say m1 over here, square brackets, r plus c plus. We're going to see in a moment how this is going to work out. Okay, this might seem a little bit strange to you, but we'll see in a moment. Okay, this is the prompt, and then we're going to read the value from the user. So depending on how many slots you're going to fill in the matrix, it corresponds to how many prompts you're going to need for the user. If you have 12 slots to be filled in the matrix, you're going to prompt the user 12 times. Okay? So now we're going to say integer, let's say value, is assigned to input.nextInt. And to be safe, also say input.next line. Okay, and now we can store this value here into the corresponding position in the matrix. So now we can say m1 at rc is assigned to val. Okay, so now let me put some comment for you. Prompt the user to enter value for the matrix, row by row, and then column by column. Yeah. Okay, let's see. And after this, we can also print out the value of the matrix just to double check. Okay, print out the resulting m1. Okay, you can say system.out.println. You can say now m1 looks like. We're going to do a test in a moment. m1, and then we're going to do just like a similar loop. Let me just copy this. Okay, this part is really the same. Okay, so now for each row, we're actually going to do system for each element system.out.print, and then m1 rc. And rather than putting a space in between the values, it might be easier to put a tab. We'll see that in a moment. It's prettier. So you can say tab is actually an escape sequence. Okay, you can also try that. And now, after each row, we're going to print a new line. System.out.println. Okay, let's see how that works. And then we'll do similar coding for initializing M2. Okay, let's try that. Enter the number. Let's say we want to do 3 by 4. Let's say we do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say we want to do this 3 by 4 matrix. How do we initialize that? Number of rows, 3. Number of columns, 4. So now, enter the value of M100. This value here, right? Let's say 1. Enter the value for 01, 2. 02, sorry, let me do it again. I accidentally hit the enter. Okay, it's 3 by 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the matrix. Okay, can I follow? Okay, good. I think the new thing you learned from this exercise here is you can see that inside the loop of matrix, you can do things like this. It just shows you there are many possibilities for your programming. Okay, and now we're going to do exactly the same thing for M2. Okay, so now I'm going to copy the code from here to say enter the number of rows in M1. From there up to over here, print out the resulting M1. Let's copy that part of the code. We're just going to copy and paste and change from M1 to M2 because those parts should be identical. Okay, let me just go back to the right spot there and then I'll show you. Okay, so now from here, enter the number of rows of M2. So now NR2. Enter the number of columns of M2 and then NC2. So now we declare another matrix M2 here. So now it should be NR2 and NC2. Okay. So now here to actually prompt the user to enter values for the matrix, we're going to say n to the length and then m to r the length. So here enter the value for m2 over here, and then n2 rc is assigned to val. Okay. And now finally we're going to print out the resulting m2. So m2 here, and then we'd say n to the length, n to r the length, and then n to rc. That's it. So now we have the code for setting up two matrices. Okay, shall we try it again? Let's say now, let's make it simpler. What about just 3 by 3 matrix? Okay. Number of rows, 3. Number of columns, 3. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's matrix 1. So now enter the number of rows of M2. Let's say also 3 by 3. Let's just start from 10. 10, 11, 12, 13, 14, 15, 16, and 17, 18. Okay, so that's matrix 2. Good. So now we got the code for setting up two matrices. But now we want to check to see if it is possible to do the addition and subtraction. Right? If you refer to your handouts there, in order to do addition and subtraction, the number of rows and columns must be identical between the two matrices. So that's what actually was said in the math definition over there. So let me give you one example here. So now let's say we want to do the following addition. Let's say it's 2 by 3 matrix. 1, 2, 3, 4, 5, 6. If you want to say plus 7, 8, 9, 10, 11, and 12. In this case, can we do the addition or not? How do we determine? The number of rows for that is 2. Number of columns is 3. Number of rows is 2, and the number of columns is 3. In this case, you can see 2 is equal to 2, and 3 is equal to 3. So that means we can do the addition. Okay? But how do we check that? That's the issue, right? We can only do the addition or subtraction if the number of rows of the two matrices match, and the number of columns of the two matrices also match. And we do have those numbers already when we actually prompt the user for the dimension size. Remember before, we actually prompt the user for NR1, NC1, and also NR2, NC2, right? So we can compare these dimension sizes. So now we're going to say that if the number of rows for the first matrix is equal to the number of rows of the second matrix, and we're using conjunction here, which means both dimension sizes should match. The number of columns of the first matrix is equal to the number of columns of the second matrix. In that case, we can do addition and subtraction. Otherwise, we cannot do it. In that case, you can say system.out.println. You can say we cannot add, subtract n1 and n2. Okay, just simple message there. But now, how do we do addition and subtraction, given that the rows and columns actually match on their sizes? In the case of addition, it's very simple. The way to do that is by creating the resulting matrix has exactly the same dimension sizes. So it used to be 2 by 3. So the result will be 2 by 3 as well. So which means we got 1, 2, 3, 4, 5, and 6. 6 results to calculate, right? So let's say if I want to calculate this one, so this one is at, let's call this N3, matrix 3. So N3, 0, 0 is going to be calculated by considering N1, 0, 0, and N2, 0, 0, and add it up together. So that will be 8. Okay, so this will be N3, 0, 1. In this case, it will be N1, 0, 1, and N2, 0, 1. So 2 plus 8, which will be 10, etc. Okay, just go to the corresponding. So basically, whenever you have R and C for N3 to be filled in, just go to the corresponding entry in N1 and M2 and add it up together. That's easy. Okay, let's see how we can do this. Okay, I'm going to do addition for you, and you can do the subtraction later on for me. So now we can say creating N3. It's going to be a 2-dimensional array. N3 is equal to, it's assigned to new integer here. So the dimension should be NR1 and then NC1. It doesn't really matter if you say NR2 over here because they are equal, as you can see from the if statement here. Doesn't matter. NR1 and NC1. So now, how do we fill in each slot in N3? We're going to use our standard loop. So for integer r equals 0, r less than n3.length, and r plus plus. For c assigned to 0, c less than n3r dot length. C so and now we want to fill in, let's say n3rc. That's simply going to be the addition between two values, m1 rc plus m2 rc. That's it. Okay? So after this, we can actually print out the value for N3. Okay, I'm just going to copy this part of the code that we did for printing out N2. Okay, copy that and put it right after the for loop here. So print out the resulting N3. Okay, so you can see, say n3 is, so now we got n3, n3, n3. Okay, and that's it. That's it for addition. So now let's try that. Let's have exactly this. Let's say 2 by 3. So 2 by 3, 1, 2, 3, 4, 5, 6. That's M1. And then another M2 also 2 by 3. 2 by 3. So you got starting from 7, 8, 9, 10, 11, and 12. After that, you got M3 being this. Okay, that's actually the correct result. Okay, any question about addition? So I'm going to rely on you to do the subtraction back home. That should be very easy. Okay, let me stop the recording here and then